Okay. So it is my privilege to introduce Wang with Towards a Learning to Rank ecosystem at Snag. Shun is a principal data scientist from the Snag data team in the DC office. Since joining Snag in 2016, Shun has been the data science and machine learning engineering lead for the Learning to Rank search products and has contributed to a variety of projects about NLP, forecasting, recommendation, and data-driven decision making.
You literally read it off.
Yeah?
Is my mic on now?
Yeah.
Okay, can people hear me? I was told that I need to raise my volume a little bit. People in the back? Okay, cool. Good. So good afternoon. My name is Shun. Like Liz said, I'm a data scientist on the MASH team at Snag. Before we begin, you should notice that this work now has double quotes. I think that's more appropriate. The original title didn't have the double quote, and it sort of felt like that we accomplished everything, which is definitely not the case. So this talk is going to be pretty high level. It's going to be mainly about a story about how we evolve LTR beyond the initial rollout to overcome some of the problems and trying to come up with new version 2 features. Some of you might know, like starting from 2 years ago, we started to work with OSC to build a learning to rank platform with Snag. We rolled everything out to production, I think, last summer, about a year ago, and we've been learning a lot from our experiences and our trials and errors. So this talk is going to be in four sections. One, about the overview. 2, about how we started with learning to rank at Snag. 3, about troubleshooting the V1. 4, about how we think about approaching V2. Snag is an hourly job marketplace. So this is very easy to explain. We have millions of job seekers that wanted to get hourly jobs. And also we have employers that are having a hard time trying to fill their jobs and their shifts. So Snag then come in and stay in the middle and say, I have a marketplace, we have a site, we have a job board site, we have some software. If people can apply to your site and we can funnel them to the employers, then they will create value by creating jobs and fulfilling the employer's employment needs. So I think everybody here knows about marketplace nowadays, but what is really special about hourly jobs? I think compared with full-time jobs, I think the number one feature here is that they're very transactional. And they're sort of interchangeable. Everybody can work on like multiple types of hourly jobs. So if you can be a cashier, you can probably be a customer service representative, something like that. And they don't stay at their job for very long. And jobs are organized as shifts, so most of them don't have part-time 40-hour work schedule. It's really like I take a shift here at this restaurant and then maybe another shift in the afternoon at the mall next doors. So this brings to another question about the characteristic of hourly job searches. And the main takeaway message here is very open-ended because the jobs are so interchangeable. 40% of our keyword searches on site doesn't even have keywords. And for the ones that have keywords, they're also super generic. And you will see on our UI that we place a lot of emphasizing to distance between jobs, schedules, and commute times, because people actually care about those things sometimes more than what they actually work on. So this brings to another point, which is your platform really about a search platform, or is it really about a recommendation platform? I had a very thorough discussion with Trey Granger last year here, and he led me to believe that it's like really like both. We couldn't live, and we have to take a hybrid approach. On the one side, we have job inventories, and we can characterize them by their positions, their employer profiles, their yield, and their locations. And if users make very specific requests about what type of job they want and where they want the job to be, then that's more of a search experience. And sometimes they also live activities on their site, and we push recommendation to them. So these two things are working, and they're useful, but really the holy grail of this whole ecosystem is you have to match. You have to sort of start with the generic search term and try to fill in the gaps by inferring from worker activities and sometimes their stated preferences, so that they not only get the job they want, but they also see a variety of options to choose from. So how do we start it for learning to rank here? About 2-3 years ago, my boss, Jason at the time, took a hard look at our infrastructure and decided our search system wasn't adequate. As probably it's very similar to a lot of the search systems out there that are now really supported by search relevance engineers. We had Solr before, and we put like an army of Boost queries on top of it. It's manually maintained. It didn't really get updated according to inventory changes. And there's really this general lack of data-driven input that you can learn from the platform and benefit from it. So we were asking ourselves, can we do better? And there's this guy called Doug that came to us and said, yes, there's another way. You can do this thing called learning to rank. And the gist of it is that if you have posting documents stored in search indexes, such that you can generate BM25 scores or even calculate some metadata about them, and if you have relevancy labels, it can come in one of two ways. One is you collect expert relevancy scores, and two, which is more applicable to our case as an internet company, is that we have a lot of implicit feedback from user interactions on our site, whether they skip a posting, whether they click on a posting, whether they apply to a posting. This tells us something about how relevant a posting is to that specific search. So we actually pulled out a team with some help from the OSC consultants to build a training pipeline. So basically the gist of it is that you take a lot of user events and posting collections from our data warehouse, historical events. And then what's really special about the training pipeline of LTR is that you have to funnel all those postings into a artificial search engine, a search index in the development environment. Then you backfill all your LTR features by making queries against this artificial index. And then you parse your labels, combining them all together, and then train a model on top of it. The one we used was actually Boost with hyperparameter tuning powered by HyperOpt. And then lastly, this ranking model is pushed into your production search engine via the Elasticsearch Learning to Rank plugin. And then our engineers also build an API layer on top of it so that our web applications can issue search requests against the search engine, and then the Elasticsearch Learning to Rank model and the plugin can service those search results. So we gradually ramp up our traffic from the new system to the old system. Like I said, it was totally off. The old system was totally off the hook as far as a year ago. So the last time we looked, and it's about a year ago, our new system actually did significantly better. The interesting part is that most of the gains are coming from those location-only searches, which is actually quite a bit of a volume of our search traffic, which is good. But keyword search was flat back then, probably got a little bit better, but probably didn't get 27% better. So the overall message here is still that the model seems to be easier to learn about location preferences from users than their actual keyword. And their actual keyword preferences, and I'm going to talk a little bit about why that's the case later, right? But now, the issue really is after we inherited the search system, after we labeled ourselves as the search team that solved all their problems, everybody's complaint got routed to us too. We're getting complaints from customers that the impression of their specific customers went down. We're getting complaints from users that specific keyword search doesn't work well. And then, like Mark was saying, everybody just wants the Google experience. So somebody actually went out and contacted Google about their job search solutions. That didn't make business sense, but didn't leave a good taste in many people's mouths. So what is going on? Why is Learning to Rank V1? I mean, it's sort of working, but why is that isn't sort of adequately satisfying users' requirements? I'm gonna just selectively talk about a few issues here. The first one, which I thought was really interesting, and I never thought about like that before Simon texted me about this sample complexity thing. That ever since I was training the Learning to Rank model, I always got the feeling that this model is really hard to train. Like if you train like a regular like price prediction model or churn probability model that I did on my prior job, it's pretty predictable. The model performance is pretty predictable. But when you train ranking models, once you put it into production, there's always some gap between what you think is going to work offline and what actually works online. And the point here is that it really boils down to the fact that ranking problem, if you think about it, is a structure problem. You're optimizing over a list of 10 or 15 job posting as a search result, essentially. But a lot of the LTR algorithms out there in the market are sort of approximating that as a point estimation problem. and which is similar to what Solr and Elasticsearch is doing, which is that they give a score to every posting, and then you rank that. You take the ranking as an implicit step derived from the actual values of scores. So what it does is that it promotes top results really well, but it lacks consideration of the sort of list-wise structure of your search result. And if you train your search result using this model, which is sort of under capacity, then you run into overfilling issues, underfilling issues. That's hard to deal with. And then lastly, think about where we're getting search logs. I mean, the database is already large enough, so you would hope that the training data is at least randomly generated. But actually, it's typically not, because your training data and your search log are typically generated by your prior search algorithms, which contain their own sets of biases. So if you have really relevant postings or items that didn't make it into the training data, you were never going to learn anything about it. So that sort of limits the amount of gain that we can achieve at every iteration. You sort of have to train a model, put it into production, induce some good behavior, and then train your next iteration of the model. Next thing I want to talk about, which is very specific to our use case, is that BM25 scores we feel is really inadequate. I think in general, they're really good at picking out the top 1 or 2 postings, but if you think about a list-wise consideration, then especially when you make the BM25 score into your RTR features, it often feels like they're too spurious. If you match on job titles and short text like job titles or customer names, it can miss many things just due to different spellings and the lack of normalization. If you match it against long text like job description, then sometimes it couldn't tell a very relevant posting that doesn't contain that specific keyword from a posting that just merely mentions the keyword that the user are looking for. And lastly, if you think the LTR labels that we got from users are easy to use, you're in for a big surprise. There's this well-known issue called presentation bias, which in a nutshell is basically saying that when users click on a posting, it doesn't really mean that the posting is super relevant. It can be influenced by a variety of different things. UI position is the most prominent one, but UX design, and also sometimes the actual yield of posting will play into some of the decisions about where we rank our postings. Also, when you collect search logs, typically the data form that you get is that, okay, I have a search result of 10 or 15 posting search impressions, and the user click on the 5th one, click on the 6th one, click on the 8th one, and didn't do anything apparently on item 10 to 15. So now you have a dilemma because you don't know whether people didn't click on them because they don't like the postings, or it's just because they were in a rush and never sort of examined those postings. So what we did is to follow industry best practice, which is we throw away all the impressions that are after the last clicked results for a user for every search session. So we'll probably lose some valuable data by throwing all those things away, but we at least sort of ensure that the data that we keep isn't as biased as before. And then, this thing I really want to talk about is search metrics. Search metric looks very easy, and NDCG is very clearly defined. But good luck in explaining that to the business executive. But really, in our case, we don't feel like NDCG and a lot of search metrics are adequate in measuring our performances. Like I said in a couple slides before, we have multi-level relevancy signals. So a click is a 1 and apply is a 2. A click doesn't generate anything, but apply it generates business value for the business. So you have a posting here that's NDCG 1, but it's not generating any applies. The model likes it, but our CEO doesn't like it. Then you have this posting like that has an apply with lower NDCG. And then I got us thinking, should we use ERR to sort of mark the maximum possible score in every search result? And it got us somewhere until you see this thing, which has a lot of applies, but even lower NDCG. So we're like, should we use maps? Or should we use a combination of map, ERR, and NDCG? So that worked for a while until one day we got a complaint from our users and from our product team that we're not showing diverse enough job postings. So this got back to the question that I mentioned about the LTR formulation being very individual score driven, but not list results driven. So the model isn't aware that this is what it's producing. It only cares about the individual score returned by each of the postings. So we have to put a lot of business metrics around measuring diversity, measuring a variety of other things to make sure that we're not over-optimizing just for search metrics. And those four are more internal to the search algorithm, but there are also issues where, are we doing on time? Okay. There are also issues that we're dealing with external influences. So this first one that we really just recently found out is that we have a lot of bot traffic on our site. And our current bot detection system wasn't capturing all of them. I think the volume of bot traffic was so high compared with actual traffic, even if like 5 to 10% of them slip through, it's going to create significant bias in the training data because bots behave significantly differently from human users. In this latest study, we actually used Google reCAPTCHA and found out that we're missing, say, ballpark 20–30% of the bot traffic or bot users from our in-house bot detection routines. So that was a new finding, and with this new tool deploy, we'll be hoping to see some better performances. And lastly, you have this thing called Google. If you have a website that's out there for mass consumption for internet users, you couldn't get around the fact that Google routes a lot of traffic to your site, and you have to sort of respect what Google sends to you or to your site, either keywords or locations. So in this example, Google rolled out something last year or even 2 years ago that allowed you to say jobs near me, and then it would geocode the search result. But when Google come up with the SEO search the SEO search result from our site, it actually doesn't pass along the geo coordinates to our site. So we're getting this weird link called part-time job near me, but it's showing pretty much all the part-time job in our job inventory. So what we have to cope with is to work with the web team to make sure, like whenever a search request is sent to our site, we always geocode them so that we minimize the amount of keyword-only searches kept on our site, which we know for a fact is underperforming compared with other forms of search results. So yeah, all sorts of problems. Some of them we had some solutions, some of them we're still striking our head around. So what do we do to do a better job? How do we evolve our learning to rank solution into 2.0? So I'm a data scientist, so the angle I'm taking is very, very data-driven, unsurprisingly. My argument here is that search engine needs a lot of metadata, and some of those metadata we might not be able to incorporate into the search engine by itself. So posting-related ones, like industry, vector embedding, those are the ones you can calculate. You can calculate before you deploy a search solution and then use it in search index to do it. But there are stuff about users, there's stuff about query strings. There's no way you can get around that by not having some sort of external API or plugins that process it. So our focus for V2 is really about collecting a lot of data and supplementing our search engine with an array of metadata services. A couple examples here. This one, before we even build any model, before we even build any metadata services, we need to have a superb data infrastructure. And luckily, this is what our data engineering team decided to do this year. And they're doing this for the whole company, but we benefit greatly from it. Our data engineer came up with a sort of a data collection and event firing system that are Kafka-based. Right? So Kafka can process streaming data in real time and also service real-time feature data to the ranking system. They also have an API layer that allows our web application to send HTTP calls to Kafka without directly interacting with Kafka. And then the coolest thing, which I like best from the data science perspective, is that we are enforcing strongly typed events using Avro schemas. So we always know what we get into, and we always know, and when people are not sending events correctly, those events will be rejected. They will not going to pollute anything we do machine learning-wise. So with that in mind, we started to think about what we can build as the next batch of metadata services. And like I said 2 slides ago, right now we focus on posting metadata because engineering-wise, those seem like the low-hanging fruits. We have 2 solutions trying to combat the BM25 problem that I mentioned probably 12 slides ago. And this one's really about job title. And this one's what I've been personally building for the last couple quarters. The basic idea is that our job titles are very noisy and it's hurting us based from an SEO standpoint or from a user experience standpoint. What we really need to do is to develop some sort of internal ontology so that we can mash very messy job title into what they're really talking about, so that we can then build on top of that, like maybe query expansions or anything like that to boost recall and precisions. This is mainly based on clustering algorithms and vector representations of our job title and job descriptions. And it's doing fairly well. I'm pretty excited about it. I'm showing it to the executive next week, and we're trying to deploy into production this quarter. The solution we have for job description, it's still sort of in its infancy, but nobody's working on it, but I sort of scoped it out. The idea here is basically to use topping model to squeeze posting descriptions like that have a lot of spamming, keyword spammings, into a collection of topics that are specified by their top keywords. And the good thing about topping model is that for every once you train the topping model, for every posting, it will also give you some sort of signal strength for every topic. So for posting like this, I think my prediction is that a lot of those topics can trigger, but most of them wouldn't have a strong enough signal to be considered a good matching signal. So we can control that by setting a threshold to the signal strengths of the topics and match only on the topical keywords on every job description. There's also this thing that has nothing to do with tuning individual posting, but has more to do with tuning, like what I said, the list-wise experience presented to the user. And in this particular case, we have a problem in that we have a lot of large customers, and they have a lot of store locations. Many of them are close. So, and they send us job templates that are then populated into a lot of those store locations that tend to receive similar scores. So what happens is that then on the surface, you will see for no reason that a particular employer is going to occupy a lot of real estate, which hurts diversity, also hurts user experience. So the approach we're taking about it is that we are using locality sensitivity hashing. So do people know what that means? Anybody? Just raise your hand if you've heard of locality sensitivity hashing before. Okay, so not a lot. So hashing, we know what hashing means. Hashing is trying to say, typical hashing algorithms trying to say, I want to put items to as sparse a hashing key as possible. Locality sensitivity hashing is doing the opposite. It's trying to say, I'm trying to hash similar items onto the same hash key. And typically the way you do it is first you come up with signatures, and that are typically powered by min hashes, which is basically you use the character engram representation of every posting, and hash them into a min hash signature. Then from that signature, you derive a series of locality-sensitive hashing functions, such that when each of those hashing functions collide, we consider that to be a good candidate for deduplication. So you run all those hashing algorithms over the signature of all your postings, then it's going to give you a list of the potential pair of candidates that you think you need to consider as deduplication, and that pretty much handles everything in linear time, as compared to if you were to do a pairwise comparison, which is quadratic. And the ultimate purpose of using locality sensitivity hashing is then we can control in the search results which of those postings are duplicates, and we'll try our best to make sure that all but one of them is shown to the user every single time. So those are some initiatives on the posting side. This one is still in infancy, but our executive, not surprisingly, consider this as the top priority that our team should be working on, which is yield management. So issue here is that every posting that posted on our site give us some sort of revenue stream, either by a click or by some contract. And the problem really here is that users, this is fundamental, and this runs fundamentally against the LTR, is that users don't have any clue about the yield of every posting. So their behavior is not going to incorporate any information about yield that's going to be useful for our yield management algorithms. So the way we're thinking about getting around that is to use really good click models to first to bias our relevancy labels from the yield considerations of our business, and then to train a clean, unbiased learning to rank model to represent relevancy. Then we're going to layer on top of it any yield optimization algorithm that could potentially work in synergy with LTR to maximize yield for our business. And we also have a lot of additional initiatives going on. Probably don't have time to talk over all of them one by one, but I think the general hunch is that we wanted to move towards more vector-based and graph-based searches. Those ideas are fun to work with on an offline setting, but it's a hassle to incorporate into Elasticsearch and make sure the scalability right and make sure the latency isn't a problem. And we're working through all of that. Lessons learned. Really just two large bullet items. LTR isn't about the machine learning model or just a search engine. You have to surround it with a lot of data infrastructure and metadata services to make it really informative, to make sure a search engine has everything it needs to do everything it wants to do. And also, once you have a search solution, typically, especially for an internet company, you have a lot of stakeholders. And some of them, every one of them wants slightly different things from you. So if you over-optimize for a specific stakeholder, otherwise it's going to yell at you and it's not going to be fun. So we have to carefully navigate through all their priorities and make sure we're delivering a solution that brings success to all of them. If you think the talk is fun, we're hiring. Are we allowed to am I allowed to do this? Okay, cool. So we're hiring data engineers, search relevancy engineers, machine learning engineers, mainly our Arlington, Virginia offices, but also some in our Richmond, Virginia offices. We have a lot of, we send like 6 people down here just to make sure we can get some resumes back. So make sure, if you're interested, talk to us, talk to me, talk to our team members, and find out about more. That's it. I'll take questions. Yeah.
You would eliminate the data. Can you elaborate on that? I didn't quite catch.
So the issue here is that imagine you have a listing of 15 postings, and on your search log you see that user didn't do anything for the last 5 ones. The problem is we don't know whether those last 5 ones are bad that the user didn't do anything about it, or is it because the user just ignored it because our users are impatient. It could be that they only look at the first 10 results without reviewing the other 5. So in those 2 scenarios, the implications are diametrical to each other. If they hate it, then those postings that they didn't look at should be labeled as sort of a negative examples. But if they just didn't have time to look at it, then we don't know whether it's good or bad, and it could be potentially very relevant listings. And if you feed the original listing into your learning to rank algorithm, learning to rank is going to think all those ignored postings are bad postings. And in our experiences, we found out that was too much. That wasn't adequate. So by removing all those segments of training data, we were able to focus exclusively on the data that we know with a certain level of certainty that the user have looked at, such that when they ignore a posting, there's a high likelihood that they just plain didn't like it. It's not because they ignored it. This gives us better relevancy labels, so to speak. Does that sort of?
Yes, but I think I had heard you indicate that after a certain number of impressions, you decided to ignore that data. Can you maybe just elaborate on the criteria upon which you decided a set of the data would be?
Oh, we're just removing the data after the user's last click.
After their last click, okay.
On a particular search result page. So if number 8 is the last one they clicked, we only keep 1 to 8. So the issue here is that they might have looked at number 9 and 10, we will never know. But well, at least we know their preferences for sure between result 1 and 8, and that's what we're going to use for the training model, to train the model.
Reset it if the criteria had changed slightly, like perhaps they had interacted with cashier, clicked, and then switched to something else, like waitress, and then
Yeah, we haven't really. I haven't really got time to look into it. This is a bigger, all the questions that you asked fall into a bigger category of topics called click models, which is trying to build a model about how users behave on your site. And that click model is probably specific to your specific set. We just didn't have the time investment to go into details to investigate the problem. So we just did the bare minimum possible to make sure our model at least worked. Liz is actually going to have a talk about click model, I believe, tomorrow. Right? So if you're interested, go to that talk too. Anything else?
Thanks. You said that you throw away all but, what was it? You keep all but one of your location-specific hashing results?
We're trying to. Let me get to that. Yeah.
So I'm a bit curious about this. You're saying all but one is shown in search results. This means that you've just eliminated one? Am I reading that right?
I make sure only one of those three shows up.
Okay. I don't know. That might be an English-US translation issue.
Oh, yeah, all but one's suppressed. Sorry about it. That should be the other direction.
Cool. That makes more sense. Thanks.
Yeah.
Hello.
Hi.
Yeah. So my question is, what's the judgment list for your learning to rank model?
Come back. I touched upon it here. We're basically taking user interactions on our site as our relevancy labels. This is what We're taking user actions on our site as relevancy labels. So if they click on it, we regard that this posting is at least relevant as judged by the user, and if they apply to it, then that means it's even more relevant. Like I said before, this is in conjunction with the click model. If you have implicit feedback like this that is not curated by experts, then you run into all sorts of bias problems that you have to then model it out. And we also find out it's beneficial when training the model to make the absolute scale of your apply event higher. So we didn't actually use 2. I think we used something like 20 or 7. So then the model is really going to be sensitive around the factors that drove user to apply to a job, as opposed to the factor that drove user to click on a job, which we don't care anything about.
So, but you said that you've used click models, right? So how did you change the judgment list from 0, 1, 2 to some other judgment list based on the session data?
We haven't implemented it, but I've read some literature. Basically, you train, and Eric is here, right? So from Wikimedia, he can tell you more about it. Basically, what you do is that you feed all those things into a probabilistic graphical model, and in that probabilistic graphical model, you define hard-coded a specific user behavior, so that those relevancy labels, 0, 1s, and 2s, become your sort of training data. And then you will be able to train from those relevancy labels a set of user behavioral parameters. And typically, how you set it up is that among those user behavior parameters, there's going to be a latent factor that's capturing what the model believes is the actual relevancy of the postings. And then you extract all those parameters out to use and sort of normalize it, and then to use as your training label.
So I have a follow-up question. So if a user clicks on a particular job posting, you consider that as a positive example, whereas all the ones before that are considered negative examples.
Yeah, if you don't click
So
on
you
it.
just have like 1 and 0. That's what you meant?
Yeah, and then we also have applies, because
Oh,
we are a
okay,
job
yeah.
site, right? Once people click into a specific link, they can see a job detail posting with the detailed job descriptions. And if they really like that, then they can click on the apply button to apply to the actual job. So we consider a click to be sort of an intermediate signal, and what we're really trying to optimize is the final signal on apply events.
Other questions? Okay. Thank you, Shun.
All right, thanks.